Hi, I'm Nick Driftwood, filmmaker and Panasonic LUMIX ambassador.
Hi, I'm John McGregor. I'm a product trainer with Sennheiser.
So what is a microphone? We're going to be going through the types of microphone and the patterns that they employ. But let's start off first with what is the difference between a dynamic microphone and a condenser?
Absolutely. So dynamic microphone, for example, this one here. Dynamic microphones work off the electromagnetic principle. So inside we have a voice coil, a loop of metal with a diaphragm on top and a magnet behind it. And if you remember from your high school physics, as a piece of metal moves back and forwards in a magnetic field, you get a current induced. The great thing about dynamic microphones is they are rugged. So you could, I don't recommend you do it right now, you could drop this on the floor and this microphone will keep on powering on. That's the great thing about dynamics. They do have a few drawbacks though. They're not very sensitive because of the weight of that design with that movement and the friction between the different components. Their frequency response is a little bit limited, and also their ability to pick up quiet sounds is a little bit limited.
So a good overall mic though.
They're great microphones, really. Yeah. When we get to condenser, so for example, this is one of our best condensers. This is our MKH8060. It's a shotgun microphone. But obviously you'll see condensers in other microphones such as Lavalier microphones and big studio microphones. Condenser microphones work off what we call capacitance principle. So internally it's a capacitor style capsule. We have a sheet of a very thin plastic, mylar, that's gold plated. Behind that we have a metal plate, and the distance between them is really, really thin, usually about the quarter of a width of a human hair. And this diaphragm is extremely light, so as it moves backwards and forwards, it moves really easily to, therefore, really quiet sounds. So that makes condensers very sensitive, which means they pick up really quiet sounds, and they've also got a really good frequency response. They'll pick up high frequencies really easily, and it means we can use them in lots of different environments where you want to pick up a really crisp sound of what you're trying to record.
Awesome. Now, obviously, a lot of you, are maybe confused over, directional, omnidirectional. What is it all about, John? Can you explain to our viewers?
Yes, the wonderful world of the polar pattern. We build microphones with different directionality into them. So, for example, here I've got it's a classic reporter's microphone. This is our MD42, and you can see on the bottom here it's got a little circle which tells us the polar pattern. This is an omnidirectional microphone. And this means that the microphone picks up sound in a 360-degree sphere around the microphone. And it's really great because it means you don't have to worry so much about positioning and how you work with a microphone. But obviously, in some situations, you might not want to use this because it's picking up sound in 360 degrees, which means it's picking up everything. When you're in an environment where you want to drop background noise, potentially, you might want to go to something like a directional microphone like this. This is a cardioid microphone. And with cardioid microphones, we reject sound from the rear. So this is great for that interview situation in a noisier environment. You can use the microphone like this. It will not pick up any of the sound going in this direction. But it does come with a drawback. It means you also need to make sure you're holding it in the right direction. So if I was interviewing you, for example, I'd have to ask the question and I'd have to move the microphone over to you so you could answer. Omnis won't do that.
And a Supercardioid.
Yeah, Supercardioid. So this is our Supercardioid microphone. This is a Evolution 945. Supercardioid is slightly different. It's like a cardioid, but we have a little bubble of pickup at the rear, which means our rejection point is coming off at an angle here. And this is probably my preferred interview microphone because if I'm holding it at a slight angle, my rejection point is coming out pretty much horizontal here, which is great. Okay. But we have to be aware of one thing with directional microphones, and especially as we go more directional, especially into shotguns, the more directional you get, the more problem you have with wind noise. So a classic one would be just the breathing over the microphone. It's going to become quite a problem. Omnis don't really have that. So you have to be aware of that. You also have to be aware of one other thing with directional, and this is getting close. The closer you are to the microphone, you get a natural 6 decibel bass boost. So the bass frequencies get boosted as you get really, really close to the microphone. It's not a problem, but it's something you have to be aware of, and maybe something you can use to your advantage as well, especially if you've got a weak, thin voice. If you want to kiss the microphone, as they say, you can get a really good, warmer, richer tone out of it.
Great. And a Lavalier mic then, so...
Well, Lavalier microphones
What's going on here?
Well, they come in two flavors. The main one that we see is omnidirectional, and that's because it allows us to place it pretty much anywhere on the body, and we can pick up sound there. But you also do get directional Lavalier microphones, and once again, you just have to be aware of working with it. But we prefer the omnis because that means you can do crazy things. Theatre people like to hide their Lavaliers inside their head, inside their wigs or their hairline, and also when you're wearing your Lavalier on the body, it doesn't matter so much which direction you point it in; it's going to pick up sound.
Can you just elaborate, John, a little bit more on, super directional shotgun mics?
So when we look at our low bar microphones, as we call them,
yeah,
these are extremely focused. So a Supercardioid will have a rather wide pickup from the front, but shotgun microphones are going to be really, really focused, nice and tight to the front, and this is why they're hyper directional, because the idea is they're like a spotlight. So they're really going to focus tightly in on what it is you're trying to record. And then therefore the applications you use them in are quite fixed as well. So boom operation on set or built in on top of a camera for getting that really tight sound and blocking out the ambient sound from the side.
One little question that I often get asked is, what are all these little grooves on the side of the shotguns?
Those are the rejection ports. So this allows the sound literally to come in from the sides, and as it's bouncing backwards and forwards inside the capsule itself, when it all meets at the capsule, they have cancelled each other out. So you're only getting that sound from the front, direct sound that comes into the front of the microphone. So the side sounds are gone.
So, John, we hear of the terminology figure of eight for microphones such as the MS2.
Yeah, so the MS2, the reason it's called an MS2 is because it's using what's called the MS technique. And the MS technique is using a cardioid microphone to the front and a figure of eight microphone to the side. So figure of eight is literally, it's a figure of eight. It's an 8 number. So I've got a bulb of sound out here and a bulb of sound out here, or pick up sound out here. And when you combine that with a cardioid microphone, you get this wonderful stereo effect. Normally, however, beyond an MS microphone, you will not see figure of eights in the filming world. It's used a lot in the recording industry, but yeah, in filming, not so much.
Well, thanks for that explanation, John.
You're welcome.
And that wraps up our quick guide to using microphones and their polar patterns with LUMIX cameras.
Panasonic.